Hello and welcome to this video lesson. This video lesson is going to look at some of the spreadsheet skills that you require for your IB science courses. To look at some spreadsheet skills, we do need some data, and to get this data we're going to be looking at this IB physics lab. And in this lab we have this photograph that shows a magnified image of dark central disk surrounded by concentric dark rings. And these rings were produced as a result of interference of monochromatic light. Do we need to know anything about what happened here? Not really. All we'll be looking at is the relationship between the diameter of these rings, and these dark rings you see here, and the ring number. So this first ring over here is ring number 1, this one is number 2, this one is number 3, this one is number 4, and so on. So we'll be looking at the relationship between this diameter, which we're going to measure experimentally, versus the ring number. Now, before recording your data, it's a really good idea to go ahead and create a table which indicates your independent variable, your dependent variable, and the number of trials that you're going to use for recording your measurements. In this case, my independent variable is the ring number, my dependent variable is the ring diameter, and I'm going to do my measurements at least 3 times. Well, I'm going to do it exactly 3 times in this case. And then I also have a column for the average and the uncertainty of my measurements. Now, after recording my set of data, I have ring numbers 1 through 12 for my independent variable, and then I measured the ring diameter 3 times. For instance, for ring number 5, I measured them to be 1.1, 1.1, 1.05, and 1.17 centimeters. I've indicated the units up here. And I've also included the uncertainty of my measuring device, in this case that uncertainty being plus or minus 0.08 centimeters. In your labs, you're going to make sure that you always indicate the uncertainty for both your dependent and independent variable. In this case, which is a special case, my independent variable does not have any uncertainty, and that is because I'm just looking at the ring number, and that ring number is a whole number, and I cannot have ring number 1.2, and I'm going to include that later on in the description of my lab so that whoever is marking my lab can actually understand that I knew why I'm not including that uncertainty. One other thing that you're going to make sure you do whenever you're putting all your numbers in is that the least significant figure for your uncertainty should be the same here, the second decimal place be the same as your measurements. So you see that all my measurements here have 2 decimal places, and that's because my uncertainty also has 2 decimal places. So the least significant figure, or the least significant digit, is the second decimal place for my uncertainty, and that is consistent throughout all my measurements. And to do this in Excel, you'll be looking at these 2 buttons up here, and if you go left it adds, and if you go right it reduces the number of significant figures. And there's another way of doing it. This is the shortcut, but if you want it in any other way, you right click, you go to format cells, and you can change the number of decimal place in here as well. Okay, after I have all my set of data entered in my table, and again I'm going to recheck and make sure that I have indicated uncertainty in the unit for all my column, and again for the independent variable I'm going to explain why I don't have that in my lab, but for the dependent variable I got my uncertainty in the units. Here I have my unit and the uncertainty with its units on these two columns, so I'm good. So now what I have to do is take the average of my trials, and I'm going to do that by writing, going to this cell over here. I'm going to write equal. I'm going to type in average, and I'm going to open up my brackets. I'm going to select the 3 trials that I've done. I'm going to close my brackets, enter, and here we have our average. And what I'm going to do, if I want to do it for all these different, all the 12 rings, instead of going and writing average for each case, I'm either going to drag this down, and when I do that, it's going to mess up my nicely drawn table. So instead, I'm going to undo that. I'm going to right click, copy, and I'm going to select these cells, right click, and go paste formulas, and that's going to take care of it. And one thing I gotta do later is go and fix my number of significant figures, and in this case I fix it by doing this. And look at that, now I have all the sort of data that I need here. Now the next thing I'm going to do is do my uncertainty, and I'm going to use the formula that my uncertainty equal to the range of data. That's my maximum value. In this case, for ring number 1, my max is 0.6 minus my minimum, so that's my range, and I'm going to divide that by 2, and that's going to give me my uncertainty. And now there's different ways of coming up with this uncertainty, and you can use either methods, but this is the method that I'm going to use for the purpose of this video lesson. So I'm going to go here, I'm going to type in equals, I'm going to open my brackets, I'm going to type in max, open brackets, and look for the max value within the set of trials. Close brackets, subtract min of these values, close my brackets. So that's my range right there inside the brackets that I just closed, and I'm going to divide that by 2, and that's going to give me the uncertainty. I'm going to copy that. You can copy by right clicking and pressing copy, or selecting copy, or you can just click the cell, press Control C or Command C if you're on a Mac, and then right click and paste special, and you can paste special using formulas. And I'm gonna make sure that my uncertainty and the average have the same least significant figure. In this case, I have to go for 2 significant figures, and that's going to, 2 decimal places, and that is going to be my uncertainty, and that completes my average and uncertainty for the data that I collected. Okay, now the next thing I want to do is figure out whether there is a relationship between my ring number and my ring diameter. So to do that, first of all, I'm going to go ahead and graph the set of data. Now, ring number, instead of ring number, I'm going to use the letter N, and for diameter, instead of diameter, I'm going to use D. I'm going to put the uncertainty in. I'm just going to copy paste it using Control C and Control V when I'm trying to paste it, or Command C on a Mac and Command V on a Mac for pasting. Once I have that, I am going to double click here so I make the sizes a little bit better. Let's enter all the data, and then I'm going to make it look a little bit more neat. So I'm going to go ahead, I'll zoom in a little bit so that it's easier to see. I'm going to type in equals ring number, enter, I'm going to drag it down until ring number 12. For diameter, I'm going to go and say equals, and I'm going to choose my average, enter, double click, equals, uncertainty, enter, click, double click, and nicely done. I'm going to press Control A to select everything. I'm going to select center and center. I am going to go to this table mode over here, select all borders, select mode thick box. I'm going to do the same thing for top here, and I'm going to select these and say Control B for bold. And that is actually, I have to change this and this into a capital U to be more consistent with my table. So here I have everything, and next thing I want to do is graph this. Okay, graph time. What I'm going to do now is I am going to select my dependent and independent variable, and I'm going to drag a window in here, and then I'm going to go insert, scatter, and make sure that you don't select line, and there's a reason behind it which we're not going to cover in this video. Is that select, scatter, go to that first one, scatter with only markers, and select it. And now we have our set of data. I don't need this series description over here, so I'm going to get rid of it. I don't need these lines. I'm going to select them and delete them. It looks a little bit more neat now. Now I'm going to select these, right click, go to format data series, and I'm going to go to marker option just to make it look a little bit nicer, and you can change this to any way you want. I like circles, I like size, smaller size. I like my main set of data to be colored in black, so I'm going to go solid fill and change the color here, and I'm going to go to marker line color and change it to no line. So that's the color of the line that covers the circle, so I don't want any color in there. So I'm gonna say go ahead and say close, and now I have my set of data all graphed, and next thing I want to do is add the uncertainties. I'm going to click on my set of data. I'm going to go to layout, error bars, more error bars. Let's select this last option here and specify value. And what that does, it lets me choose my plus or minus values for my uncertainty. And the way I'm going to do that, for positive error values, I'm going to select this, delete it, and instead select these set of uncertainties. For negative, I'm going to do the same, select, delete, select these, go OK, close. And now I don't need the X part of it, so I'm going to select these, delete, and look at that. Now I have my graph with all of the uncertainties. Next thing I'm going to do very quickly is add titles, X and Y titles to the graph. Alright, now to add titles, I gotta stay at this layout tab over here. I'm going to go to axis title. I'm going to go to primary horizontal axis title, title below axis, and I'm going to enter ring number. And I don't need a unit for this section, so I'm just going to keep it as is. And then I'm going to go to axis again, primary vertical axis, and then I'm going to go to show default axis. Oh, sorry, I'm going to go axis title. I'm going to go to vertical axis title and rotated title. Excellent. This is my diameter or ring diameter. So we can go both ring diameter but I do need a unit here, and that's going to be in centimeters. I'm going to leave that in. And to make things a little bit more neat, I do want to change some sizes here. So here the ring number, I want it to be a little bit bigger, indicating that those are titles. This is 14, 14. That looks a little bit better. And everything else looks okay. So now I have my set of data. The next thing, oh, whoops. Next thing I'm looking for is whether there is a relationship between the set of data. So if I click on one of these data points, right click and go add a trend line, I can see that it doesn't really fit really well through a linear line. It more looks like polynomial function, and in fact if I go ahead and select that, I can see a much better line that fits through the set of data. So now I know that my ring diameter and the ring numbers are not proportional. So the next thing I have to look for, so what I'm going to do is delete this. So in my lab, I'm going to go ahead and indicate that the ring diameter and the ring numbers are not proportional, and that we need to look for a difference relationship in order to figure out whether what is our ring diameter proportional to, and that's what we're going to look at next. Alright, before talking about the relationships, let's quickly talk about how we can enter a chart title. So one way to do it is to click on the graph, go to layout, go to chart title, and we can do above the chart, and then we can enter the title over here. The other way that you can do it is just copying the graph, going to the Word document where you want to paste it, right click, and then go to paste, and I'm going to use paste special, and I'm going to do it as a picture. There's advantages and disadvantages of doing it as embedded workbook or doing it as a picture. Here I'm just going to do it as a picture. I'm going to make it a little bit smaller. I'm going to go home, center it, right click on it, go to insert caption, go to figure 1, and enter the title over here. So this is going to be ring diameter against ring number, and you can name it. It all depends on what you want to name it. And if this color was not black, or if you want to change this color, you can always go to captions here, right click on it, modify, and then change the color over here. So here I'm just going to go black, enter, and that caption color is always going to be black from now on. Now the advantage of doing this, and again you can do it in different ways, I like it this way because when you're talking about this graph on your lab, you can just refer to it as figure 1. Say figure 1 indicates this, that, and that, and then you'll have different figure numbers, and you can refer to it in that sense. And again, if you're writing a bigger document, and if you are writing, and if you're trying to insert a table where all the figures are there, you can go to references, you can go insert table of figures, and you can choose different settings for it. Go OK, and look at that. It says figure 1 ring diameter against ring number, and that's on page 1. And as you change the page number, let's say I put this in page 2, go back, or page 3, I'm going to right click on it, I'm going to update field, update entire table, and look at that, it actually changed the page number in there. And again, if you change this figure title as well, just change it to ring, go back. Let's change it to page 2. I don't know why I put it in page 3. Now it's on page 1 again. Anyways, you can right click, update field, tire table, and now it says ring on page 3 because it went back to page 3 again. The title is there, so let's bring it back up here. Now it should say page 2 when I update it, and you can see that it does. So it's very useful for having a table of figures, which is actually an important thing when you're writing an IA or something along those lines, some document which is much longer. At the moment we can see that our graph is, or the relationship between the ring diameter and the ring number are not proportional. And we can see that because this is not a straight line, we can't fit a proper straight line through these points. And also it wouldn't touch the y-axis at 0, so it's not proportional. So the next thing we're going to try to do is figure out how we can change either our dependent variable or independent variable to make this relationship proportional. So I'm going to move this a little bit here, and then we're going to go ahead and look at what we're going to do next. Now I'm going to experiment with my set of data a little bit to figure out what kind of relationship exists between the ring diameter and the ring number, or variable and independent. So I'm going to resize this a little bit, bring it here. I am going to make this a little bit bigger. We don't really need to look at the uncertainties for now. I have my average here, I have my ring number here, and I'm going to go ahead and look at how I can make my relationship a linear or a relationship in which the my independent and dependent variables are proportional. So first thing I'm going to look at is logarithmic. So I'm going to look at log of d, and I'm going to go ahead and say equals log, and let's just do log 10. Whoops. Let's do log 10, open brackets, and go average. And I'm checking here to see whether my n and d values are logarithmic, or if they have a logarithmic relationship. And as we can see, once I do that, set of data is no longer, it's not linear at all. So I'm going to go back. So I'm going to press Control Z, Control Z, Control Z, Control Z, and that undoes my work, and I'll go back to what I had before. So this tests logarithmic functions and figures out that the two relationships are not logarithmic. Also check the inverse relationship. So I can go ahead and say what happens if I go 1 over d. And when that happens, I'm going to go say this is equals to 1 divided by the diameter. Say OK. And I'm going to drag this down. And you can see that the inverse function is not proportional to the independent variable either. And I can try different things as well. I can go 1 over d squared. So here I'm just going to go to squared, and you can see that it's even worse once I do this. So the next thing I'll look at is whether they are proportional using an exponential function. So here I'm going to go to d squared instead, and I'm going to go and say this is equal to my average squared, and I am going to drag that down and look at that. Okay, first thing I'm going to do is I am going to change my values a little bit so you can actually see it. And now I can see that this looks a lot more linear than what I had before. In fact, if I draw a straight line, it's very close to that zero intercept, or y-intercept of 0. Obviously there's going to be systematic errors which will cause that line not to go through the y-intercept of 0. But if we take a few outliers away, maybe this point over here, this point over here, the relationship is more or less linear. So I can, using this analysis, I can see that my the diameter squared is proportional to the ring number, or the ring number is proportional to d squared. Both of them work here, and well, that's nice. So the next thing I have to do is redo my work showing how d squared is proportional to n. And what I'm going to do is go Control Z, and I'm going to go back to my original graph. Because what I have to do in my lab is I do have to indicate or show this graph first, say that set of data are not proportional, and say that using an analysis I found that the dependent variable and independent variables are proportional, where only in the case that d squared is proportional to n. And later on I'm going to graph that, figure out what my slope is, and use the maximum and minimum slope to figure out what are my uncertainties of that slope, or what is that proportionality factor. So that's what we'll do next. So now that I have figured out that d squared is proportional to n, I have to make a new table where I have n as my independent variable and d squared as my dependent variable, and I will still have the uncertainty. This will be a new uncertainty, and what I have to do is make this to a square. So I'm going to right click on it, go to Format Cells, go to Superscript, press OK, and that's nice. And then I'm going to go ahead and say this is equal to the ring number down here. Just enter, drag this down, and I will have all my ring numbers, and then I'm going to go ahead and say equal to the average squared. I'm going to use and to do this hat, I'm going to go ahead and press Shift 6, and that indicates that it's square relationship. And I'm going to drag this down, and I am going to right click, go to Format Cells, I'm going to go to Number, I'm going to go to 2 significant figures, and that's going to fix that. I'm going to double click here, a little bit bigger. There we go. And for uncertainties, now for uncertainties, when we square a value, the uncertainties, we have to propagate the uncertainties. So the way we're going to do that, and again you will learn this later on in your course, but to propagate a square error on a squared term or a squared measurement, we have to double the percentage uncertainty. So I have to go 2 times percentage uncertainty, which is the uncertainty divided by the original value d, and I have to multiply that final value by the d squared value. That's going to give me that uncertainty that I need. and again it has to have the same least significant figure, so that is 2 significant figures. So I'm gonna go ahead and press the wrong button. I have to go ahead and do this, and now I have the proper values. I'm gonna drag it down. I'm going to make a nice table out of this by going to all borders, thick box, Control B, and I am going to select all the table using Control A or Command A on a Mac. I am going to go ahead and select center twice to center things, and center here. Make this a little bit smaller, make this a little bit smaller, so that things are a little bit more neat. Oh, and obviously I forgot to do something, which I will do in a second. Here I'm going to double click this, and here for d squared I need a units. I have its uncertainty to the right, so I don't have to include that in there, but I do have to say that this is, I'll just write it out, centimeter squared, and I have to put this into brackets, and I have to go ahead, and this is a little bit tedious work. Right click here, format cells, take the superscript off. I have to do the same thing for this section. Right click, format cell, take the superscript off, and here I have my unit as well. So when I put this into my lab, it's easy to figure out that here is my unit and here's my uncertainty. The unit of my uncertainty is there, the plus or minus are there. So everything is looking good for this table. Final thing we have to do is to graph it. What I'll do first is move this graph down, because that one is already done, finished, and all we need to do with that that chart or graph is to put it in our lab and talk about it. So we'll do that, so you can do that later. Next thing we'll be looking at it again though will be how to graph this, how to draw the line of best fit, and so on. So that's the next step. Alright, we're almost finished what we need to do for this lab, or in terms of graphing. Next thing I have to do is graph this by going to Insert, Scatter, right click on my set of data, go to Format Data Series. Again, I'm going to do what I did last time. I'm going to use circles. I'm going to go for a size of 4. I'm going to go to color solid. I'm going to use black. I am going to go to mark line color and then go for no line, and that is it. Here I'm going to get rid of this series. I am going to get rid of these lines. I am going to select this, right click it, go to add, oh actually before this let's add my errors. So I'm going to go to layouts, I'm going to go to error bars, more error bars, and I'm going to do exactly what I did last time. I'm going to select the positive values of my propagated uncertainty. I'm going to choose the negative values as well. That's good. Okay, I'm going to get rid of this. I am going to get rid of this horizontal ones. And finally, I'm going to click on the set of data, right click, add trend line. I'm going to, okay, now this time I am going to go ahead and say display equation on the chart, and I'm going to make sure that this linear relationship is selected. For line color, I'm just going to use black, and then I'm going to go ahead and say close. So that's nice. So everything is here. I'm going to go enter and say line of best fit. That is my slope. I do want to change the number of significant figures because I don't want to have 4 significant figures. That's what is calculated by Excel itself. So let's go for 2. Should we do 2, or we can do 3 significant figures? For now, I'm just gonna to show you how things are done, and you can change these significant figures for your specific lab. For this one, I'm just gonna use 3 significant figures. So I'm gonna go ahead and change this to a 1, just using my keyboard, and I have to change this to a 3 to be consistent. And that shows the systematic error, so the line doesn't go exactly at 0 but a little bit higher, but it's pretty nice. It goes to show that our set of data are really well done. Here I'm gonna go ahead and add axis title, and this one is going to be ring number, or I can just do n. I'll just do ring number. I'll just do n. And here I'm going to also go to axis, vertical, rotate it. It's gonna get a little bit tedious. I'm going to type in the squared, and the unit is centimeters squared. And I have to do exactly what I did last time to get the squares. I haven't found a better way. I'm sure, actually there might be a better way. I'm going to go to font. I'm going to go to superscript. And I'm going to do the same thing here. So, just use some shortcut there. Alright, so that is nice. D squared centimeters squared is the relationship there, and the line of best fit is there. I can make these a little bit bigger. So home, size 12, size 12. So that's nice. The numbers are nicely written. This I'm also going to change to 11, much better. Make this a little bit bigger. You might need to change the sizes a little bit as well. But this is fine right now, so I'm going to keep it as is. Next thing I have to do is add a maxima and minima slope here. So the maximum slope and the minimum slope, and that is the maximum slope is taken from the minimum point here to the maximum point there, and the minimum slope is taken from the maximum here and minimum here. It's not always the case. So it can be done differently. This is the one method that is consistent with a lot of work that has been done previously in the IB, so I'm going to teach you that method, and again you can use a different method if you want. I'm going to go ahead and type in maxima here. I'm going to dedicate 2 cells for it. This is going to be my independent variable, so that's going to be n. This is going to be d squared. Actually, I'm going to do 3. I need the uncertainty, and I need the n value. And then for n value, I'm just going to use the very first point and the last point. It's maxima. Actually, I don't need the uncertainty here. Never mind. So I will clear that. And I am also going to do minima. So I'm going to go minima, and I'm going to select, copy these, paste them, dedicate 2 cells over here so things are a little bit more clear. I'm going to go for n1 and 12. And for maxima, again, I have to choose equals to this value minus, so that's my lowest possible value, the uncertainty. And for this one, I have to choose the maximum, so I'm going to choose the average here plus the uncertainty. That's my maximum. For minima, I gotta go ahead and say equals to, this time the maximum in the beginning, that points right over here, and go ahead and say plus the uncertainty. And for minima, I'm gonna go ahead and say equals to this last one minus the uncertainty, and that is this value right over here below, using the average and the error bar in the bottom. So that is nice. So next thing I'm going to do is make all borders thick border, and do the same thing here. All borders thick border. Make things a little bit nicer. Again, you don't actually need to put this graph in there in your lab. It's just there to determine the maximum and minimum slope. Okay, so now that I have this, I'm gonna have to add those set of data in here. So I'm gonna right click on my graph, go to select data. I am going to go ahead and edit the first set of data and put a name for it, and I am going to say that this is my main data. So I'll just put that in so that I know what the set of data are. I'm gonna go ahead and add series name maxima. I am going to select the x values here and y values. I'm gonna click these, erase this, and then add these settings. That sometimes help to reduce some errors caused by Excel. So I'm going to go ahead and say okay, so that adds 2 new points to my set of data. That's this point and that point over there. That will help me determine the maximum slope, and then I'm going to go ahead and say add minima. X values for this is going to be here, the y values is going to be here, and that is my other set of data. So that's nice. I'm going to go ahead and say okay. I'm going to change a few things. First of all, with this set, I'm going to right click, actually let's format, let's change the colors. For maxima, I am going to, let's change the marker option first. It's too big, so I'm gonna go ahead and choose 4 again. You can choose 3 if you want as well. I don't want color here, and for marker fill, I'm gonna use a solid pattern, and I can choose blue. I'll choose a light blue so I can later on see exactly which one is the maximum and which one is the minima. I'm going to go ahead and close this one. I'm going to do the same thing here for the minima. Right click, format data series. I'm going to go to marker options, use a circle, 4, size of 4. I'm going to choose a nice red. Going to select no line here. Okay, that's good. So now I can right click on this and add a tread line, and there's only 2 points, so you kind of get a perfect linear relationship there. I do want to display the equation and go ahead and say okay. After I've done this, I'm going to select this line, right click, go ahead and go format tread lines, and and I could have done this before, I'll do it better next time. You can go to line, color, and right away let's change the color to using the maximum. So I am going to choose this color, so that kind of indicates that that color is for maximum slope. And I'm going to go ahead and change the color of this text as well to this color, and I'm also going to go ahead and edit it a little bit, say maxima or maximum slope, whatever you desire, and this would be for 9. 1, 2, 3. Get rid of that. That's nice. So I'm going to put that up here. And finally, I have to do the same thing for this one. Right click, add tread line, linear, display equation on charts, line color, solid line, and choose my nice red. Okay. And I have to drag this down. This is my minima. And I'm going to select the box and choose my other color, indicating that this is my minima. So that's nice. Everything is now clear. So I have my maximum slope, which is about 0.249, line of best fit 2.41, and minimum, which is 0.21. And I forgot to change something here. I am going to have to change the significant numbers here, so this is actually going to be 0.77. Okay, good. Okay, so the last thing we'll look at is if we have a lot of lines over here and a lot of slopes, sometimes it makes it a little bit difficult for the person who's marking it to really realize or figure out where each line is. So to help with that, what we can do is display two different graphs, one with just the line of best fit and one with the maxima and minima, and that will clean things up a little bit. So what I'm going to do now is I'm going to move this graph down here. I am going to right click and copy it. I'm going to go down here, right click and paste it. I just want to paste it, so I'll just use Control V and Control V again here. So now I have two different graphs. What I can do for the first one, I just want a line of best fit in there, so I'll select this set of data points, delete it, and the set of data, delete it, and that gets rid of everything. This thing pops up, I don't know why. I'm going to delete that as well, and that looks a lot nicer. And I'm going to go ahead back here and get rid of only my tread line. So go ahead, get rid of this line. That gets rid of those, the slope and the tread line and its equation. Makes it a little bit cleaner, which is nice. And here I have my set of data, which look good, and I can just use these two graphs to show my line of best fit, so the average line and the maximum and the minimum slope, and then use these set of information. So now I have my three slopes. My maximum is 0.249, my average is about 0.24, and my minimum is about 0.214. So I can use this now to write out the rest of my lab report. I hope this video helped you a little bit with figuring out how to use Excel in the future. And if you have any questions, you can always go back and look at the different stages of this video, and you can also always contact me if you ever have any question. Thank you very much for watching, and have a wonderful day.